talking about computer vision and using AI, like if someone has an idea and thinks like this is a really really great, I need to do this. What should they know? What are the things that could potentially put it off the rails or make it successful?
I would name two major factors of success. One, maybe three. One is business. There should be business effect in your project. If you are not able to save or make money using your application, then it's probably doesn't make sense to implement that. So analyzing your business case, understanding the factors is key in the very beginning of the project. That's the first thing, the business application. The second one is technical feasibility, and that would include if you have or are able to get enough data, because AI needs data. It feeds on data.
So if you're starting a new project, do you typically have people already have a data set, or you're helping them collect it and massage it to what you need?
It can be both, but usually there is some data available, but usually we need to collect it.
Okay. So what
from the scratch?
What is a realistic? I mean, we all know it's like you need a huge amount of data, but like, what is the level that you need to like actually make it reliable enough to like make a decision?
It depends on the pipeline heavily, but I would say that the ballpark estimation would be if you have thousands of data points, that is sufficient for the start.
And how does that affect? Okay, yeah, for the start, then like how does that affect like what you would see as your it's working or not? And like when should someone be like, oh no, this is terrible versus like versus not?
It's a good practice to establish your success metrics early on, understand clearly and write it down. How will you measure success? And then to have data, a test data set that you will use to measure the effectiveness and the accuracy of your models. So preparing this data set is, you should put a bit of effort in there so that it represents the variety of cases that you are expecting to happen in your production process. And you just use your models that you get in the process as you work on your system. You apply these models to this test data set and you see how far you are from your goals and targets on accuracy.
So what would that mean in practicality though? So like we have thousands of images and we are like, let's take it the case of the beer packaging, right? Now they have a ton of images and they have a ton of cans, and somehow you have to correlate the statistical effectiveness versus what's really happening. So like, what does that look like and how are you involved?
Usually have a bunch of data, right? A bunch of images. You just split them in different buckets. And normally it involves a lot of human effort to label it and just to look it through to establish so-called ground truth, when we exactly know when there are defects that we're looking for or when there are images without defects. And you use one bunch of images for training models and a different one for testing. Also, a good practice is to have a so-called validation data set for hyperparameters adjustment. But let's just, for simplicity, put it as a training set and a test set. These are the images that are taken with the same camera, with the same setup. It's just one is used for training and another one is used for testing the model.
So if you're refeeding the model the same images and then you're like doing a reinforcement of something that's wrong, then it's like you're just making an echo chamber, right?
Yeah, it is called overfitting, and it is quite often used by data scientists to fake the results. So you should be aware of that. If you are working with a group of data scientists, you should be very aware of what data you use for training and what data you use for testing, so that it's not overfitting. Is when you train the model to work very good on a very narrow selection of data, and once you apply a bit different data to the same model, it will fail.
Right. In a real practical application, like, can you think of something where if someone was coming to you, they thought like, oh, this should be super easy with computer vision, with AI, like when is it actually not easy? Are there certain cases where like it would be a pretty big effort to make it work?
I would say any real production environment is not easy. At least the majority of cases are way more difficult than they may seem. Especially if people are used to see how good AI works on their mobile phone for photo editing, for finding objects on your photos. But the thing is that the real world, the real application, especially in the manufacturing environment, they are usually mission critical. So it's really difficult to make a system that will work in close to 100% of cases. So
Right.
it's easy to make a system that works in 70% of cases, 80%, even 90%, but each additional percent of accuracy will be more expensive and more resource demanding than the previous one.
Yeah, and I mean, even with engineering or controls engineering, at least in my case, like I'm thinking of things like are deterministic, right? If you can assume that everything's stiff mechanically and like it goes to this position, it's going to do that thing every single time. In vision, even just traditional vision, that's not the case. It's like it's magic, right? And we all know it's not. That almost is like a culture shift of what is expected in manufacturing and certain regulatory areas. It's kind of difficult to know like how AI would be applied.
Absolutely.
What are some ways that some solutions to that? Because obviously you still think AI is a good idea.
Again, having a good business case, a solid business case is very important, because a solid business case means that you can invest enough to get to the finish line and implement your system, and not to finish your project too early.
Mm-hmm.
And the second thing would be to collect data and to look at objective data and to try to understand as much nuances of the environment and just observe the environment as much as possible. Not just use the data that you've got, a data set, and for example, your customer or your colleagues, they say that data set is sufficient to represent the process. The best thing is to go with your own on your own to the manufacturing side and spend sometimes several days, a week or two in the manufacturing process and understand it deeply, so that you can see the variation factors. For example, there can be some seasonalities involved with the time of the day, also with the season. The temperature may go up, or humidity, and your image on the camera may somehow change. So it will all affect the accuracy of your model.
But also is the thing we're trying to solve, right? Like that is why traditional computer vision, or I mean cameras and manufacturing do fail, right? Because like I'm actually working in a project right now where, a certain time of the day, like the machine just literally doesn't work, right? Because of the light. And so that's where the gap we're trying to close as well. So, if you could get it to work and you have the effort to invest, then the payback is high as well.
Yes, absolutely. And the difference with the traditional and AI approach would be if you find this gap where a system doesn't work. With traditional engineering, you would most likely create new rules. And with AI, you will add more data to the training data set.